For today's video, we will be talking about terminal alkyne elimination. And so for this, we would start actually with a single bond in alkane, and we would make it into a terminal alkyne. So not just any alkyne, but a terminal alkyne. And the reagents we will use for this would be NaNH2 over NH3. The NH3, it wouldn't be really that much as a use in this case. Our second reagent would be water, right? So start with a single bond and make it to a terminal triple bond. Okay, so terminal alkyne. So if we have our first example, and we're just going to do the products for this case, you have an R group connected to two carbons, connected to the hydrogen, and we have two bromines and on this carbon, and we have a hydrogen on this carbon. And this is reacting with the reagent that I have just said, NaNH2, okay, NH3, and so also with water. And so from here, the thing you want to do for our products is actually remove the hydrogens, all of the hydrogens, and also remove the Br, okay? And this will have a formation. When we do this, you would have forming a triple bond, which a product would be something like this. Triple bond between those carbons, okay? And that carbon would have a hydrogen at the end, okay? Connect to a hydrogen. And altogether, this will be added with a reagent. I'll show you when we do the mechanism, but in OH group at the end. An OH group at the end, okay? So all we do for here is just remove the hydrogens, all the hydrogens and the bromine to get our triple bond. And so for this equation, this is our product. Let's see another example where we draw the products for it. So if we have this structure, actually this alkane, and it has connected a Br with it, and a Br, another Br. And again, this is reacting with the same reagents. So the first one would be NaNH2 over NH3. Again, NH3 will not be used as much in this reaction. Our second reagent is water. So from here we have actually, let's draw out the hydrogen, one hydrogen, and we have another hydrogen here, so that's two, and then we have another hydrogen over here. So our goal is to actually remove both of the bromines and all the hydrogens as well. Okay, and so when we have actually two or more hydrogens to remove, we would actually use not one NaNH2, but in this case we have three hydrogens, so we're going to have to remove, we have to put excess, okay? So actually let's put excess meaning more than one, basically, two or more, okay, excess NH2, okay, and that's our first product, okay, because we have three hydrogens, that's why we use excess of NH2, meaning like three equivalents or two equivalents of NH2, we're going to use it twice. I'll show you when we do the mechanism for this, but in this case, we will have a product that would look like this, a terminal alkyne forming over here. Let's count the carbons. We have 1, 2, 3, and 4 carbons, and this we have 1, 2, 3, and 4 carbons over here. And so again, we would actually have OH at the end, and OH would be, when we do the mechanism, we would have the OH added, but in this case, you don't really need to do it if you're only drawing the products, but it'll be better if you do. So this is the product for this. Let's do another example. Hydrogen connected over here, and then we have two bromines, and then we have two hydrogens over here. So as you can see, we have three hydrogens here. So for this, we would actually be using excess, okay, so more than one NaOH to get rid of the hydrogens, okay, and also the bromines. So NH2. Again, you don't have to write the NH3, but I'll just show you. Do it just in case. NH3, and our second reagent is water. So again, all we do is we start from a single bond, an alkane, and we have to turn it to a terminal alkyne, right? So in this case, we remove all the hydrogens and the bromines, and they will form something like this. I'll show you in the mechanism later, but it will form a terminal alkyne. So redraw the molecule. Okay, something like this actually. Let's count the carbons if this is right. 1, 2, 3, 4, and 5 carbons. And in the structure, you have 1, 2, 3, 4, and 5 carbons. So we have the exact same number of carbons. That's what we want. We don't add or take away any carbons. Again, you don't have to write this for the products, but we do end up having an OH with it. But this is actually if you draw the structure, that'll be correct as well, only. But this is the full product for it. So now let's draw the mechanism for this. If we have this, and Br bromine here, and then we have the 2 hydrogens on here, and also we have the hydrogen here. And so for this, we see that there is 1, 2, and 3 hydrogens, and we're going to have to use excess of NH2. So let's draw the first step. So excess of NaNH2. Again, you don't have to write the NH3, but just know that it's there. So when doing this mechanism, let's just first slowly work with 1. Let's not add the water yet, but we'll add the water after. So in this case, if we have this structure, and first thing you want to do is when you have the NH2, it doesn't matter where it doesn't really matter, but for this structure it doesn't, but I'll show you when we do the other ones. Typically we would kick off we start with the hydrogen on the end over here, and we'll kick off the bromine adjacent to it. In this case, it doesn't really matter what we do here. So we draw an NH2. Let's have 2 lone pairs with a negative charge. From here, one of these lone pairs goes and grabs a hydrogen, and from here, it gives off its electrons, the bond, to form a double bond here, right? When it does this, one of the bromines gets kicked off right here. So we would have a structure that would look like this. Now a double bond is formed from the hydrogen. The hydrogen here is gone. And we have 1 hydrogen left on this carbon. Let's connect to that carbon. We still have this hydrogen and the bromine over here. Okay, and plus what we made, which was the NH3, but you don't have to worry about it too much. NH3 that we made from here. So from here, again, we have excess, right? So we can use another NH2. Alright, so the NH2 again would come, negative charge, and it would kick off, it will grab, let's say, oh, actually, no, oops, I messed up on this structure. It's not hydrogen, this is a bromine. Okay, let's pick up this hydrogen. This grabs this hydrogen. This hydrogen gives off some electrons to form a triple bond over here. When it does that, it'll kick off this bromine by itself. So then again, our structure would look like this. Now we have that triple bond that we wanted, left with 1 hydrogen. Okay, but we want to get rid of this hydrogen. Okay, so we have excess, right? Let's use that one more NH2 again. So excess NH2, 2 lone pairs, a negative charge. From here, it grabs the hydrogen. Now this hydrogen gives off the electrons to the carbon, right? This time we don't kick off a bromine because we don't have any bromine left. So it's only 2 arrows shown. So this then would have a mechanism that would look like this. Triple bond. Now this carbon has 1 lone pair with a negative charge. This is where the water comes in, right? So this would react with water, right? Water, a second reagent. Okay, it would come in our problem. Okay, let me just write it over here as well. It comes in our problem. So now, what we do from here, we want to get rid of the negative charge. So what we do is draw water, the hydrogen, and the hydrogen. So now this lone pair goes and grabs a hydrogen, which this gives off electron to oxygen. So we'll form a something like this, and plus our OH that we have made from the mechanism. And so this is the mechanism. This is our answer for this problem. Let's do another one, the one we had drawn before. So we have bromine over here, and we have another bromine over here. This carbon has 2 hydrogens, okay, and it has 1 hydrogen over here. And so from here, it's reacting with the same reagent we have been using. Let's start off with NaNH2. Actually, no. We have 3 hydrogens, so we have to use excess, more than 1 NH2. So NaNH2 over NH3. Okay, so from here, drawing the mechanism. All we do now, let's start with the hydrogens on the end, which would be easier. So here, let's start from here on the NH2. Okay, when that happens, NH2, negative charge, grabs this hydrogen, gives off the electrons to make it a double one over here. This bromine gets kicked off. Okay, so it's the adjacent bromine of the hydrogen. So not this bromine just yet, but actually this bromine would get kicked off, expelled. So we have a product that would look like this. We have the bromine over here, and we have the hydrogen, the one other hydrogen over here. So let me draw on the other side. Now this bromine's gone. We're left with the hydrogen over here and a double bond that was made. Oops, double bond that was made. Okay. Now again, we use NH2 again because we have excess. Let's pick this side. So NH2, 1 lone pair, grabs the hydrogen. Okay, now gives off this electrons of hydrogen, forms a triple bond. Well, this expels, this bromine expels. Now we have a problem that would look like this. Hydrogen over here, and we have a triple bond. Okay, since we have 1 more hydrogen, let's get rid of it. Okay, let's get rid of it. It's better. One more time, NH2 would come, grab the hydrogen. This hydrogen gives off electrons on that carbon. There's nothing to kick off, so let's react it. Oops. Okay, we have this. With a lone pair, negative charge. Now this is where the water comes in, right? This reacts with H2O, water, our second reagent in the step. Draw water. Okay. Water grabs the carbon's lone pairs grab that hydrogen. That hydrogen gives us electron to oxygen to form 3 lone pairs. So then we would have an answer that would look like this. You can draw it like this. You can. Okay. But plus the OH. But for this case, I would actually make it look better. And you should already know that the hydrogen is over there in the product. Even if I don't show this, there's always a hydrogen there with OH that we have made, and this is our final answer for this problem. Let's do another problem here. We have this structure. We got bromine over here, and we have a hydrogen, and then we have a bromine, and we have a hydrogen, and then we have this structure over here. And it's reacting with the same reagent we had been using, excess NaNH2, because there's more than 1 or 2 hydrogens, and over water. So the first step is to add the NaNH2. So we're going to add the NH2. It has 2 lone pairs with a negative charge. And from here, it would grab hydrogen, right? This hydrogen breaks this bond and forms a double bond here, and it'll kick off the adjacent bromine to it like this. And so we would have a product that would look like this, double bond forming here. We still have the bromine on this side, and then we have the hydrogen sticking over here. The bromine has expelled, has left, and we only have left the hydrogen here, and this is with the NH3 that we had made, actually. Don't worry too much about this NH3. It's just there. So next, NH2 comes again because we got to kick off the other hydrogen, grab the other hydrogen. So it grabs this hydrogen breaks bond forms a triple bond, which will expel this bromine out. And so from here, we would have a product. We would have a product that would look like this. Just one hydrogen, and we have the triple bond that we want, right? But we got to remove this hydrogen, so this is where we bring the NH2. We are not done here, because we have to do the water portion. So it grabs this hydrogen. This hydrogen breaks its bond, gives it to that terminal carbon. So from here, we would have a structure that would look like this. Okay, so as you can see, we still have the same amount of carbon at the beginning. This is the first structure. 1, 2. No, actually, no, it's not right. 1, 2 over here, 3, and then 4, and same here. 1, 2, 3, 4. We have to draw it like this because alkynes must be drawn linear. So from this portion, it has a negative charge. Actually, let me erase that. Has a negative charge on this carbon, one lone pair, right? So from here, the water reacts, right? The H2O will now come in this place, and so what it does here, water comes in, will deprotonate that carbon, remove that negative charge. So this lone pair goes and grabs this hydrogen. This hydrogen gives its electrons to oxygen. It will form OH. So from here, we'll have a reactant that will look like this. You can add the hydrogen here, but you don't have to, but you should know that it's always there. And the plus the OH that we had form. And this is our final product for this mechanism.